Welcome back to Backspace Academy. In this lecture on deployment on AWS, we'll start off by talking about the concept of infrastructure as code and how we can manage our infrastructure with the same version control tools that we do with our code. We'll then look at the different options that are available for deploying applications. Then we'll look at how we can deploy applications that are containerized. And finally, we'll talk about the different strategies that are available for deploying our infrastructure. Infrastructure as code is a term that you'll hear a lot in AWS in relation to deployment. What it means is that we can define our infrastructure in a text file, and using the CloudFormation command language, we can define very complex architectures. And when we do that, it allows our infrastructure to be managed in the same way that we manage our software. And a big advantage of that is that we can apply version control to our CloudFormation code. There are two examples there of CloudFormation. We have CloudFormation templates and the CloudFormation designer. CloudFormation templates are simply a text file which contains CloudFormation commands in JSON or JavaScript object notation or YAML format. And those are read by the CloudFormation service to deploy a stack of our resources. The CloudFormation designer takes this another step further in that we can actually design visually our architecture on the screen. And then the CloudFormation designer will automatically produce our JSON document for us. And all of this can be managed using version control. The process starts by us creating our CloudFormation template text file, which will be in either YAML or JSON format. And that will define, using the CloudFormation command language, it will clearly define our entire infrastructure. When that has been created, we can then upload that to Amazon S3. And then from there, we can go into the CloudFormation service and either use the command line tools or the management console. Or of course, we could also use an application that uses one of the many software development kits. Either way, you will use the CloudFormation service to read that CloudFormation template in that Amazon S3 bucket. And then the CloudFormation service will create a CloudFormation stack that will contain all of those resources that are defined in that template. Here we have the CloudFormation designer. And up the top there, we can see that we've got an architecture diagram that is showing all of our resources and the interactions between those resources. And on the left there, we can see the list of resource types that we can simply drag and drop onto our CloudFormation designer screen there. And down the bottom there, we can see the CloudFormation template that has been automatically created for us based on what we have drawn in the CloudFormation designer user interface. AWS OpsWorks is a configuration management service that is fully managed by AWS. There are three options for OpsWorks. The first one there is OpsWorks for Chef Automate, which is a fully managed installation of Chef Automate. And there's OpsWorks for Puppet Enterprise, which again is a fully managed installation of Puppet Enterprise. And we also have AWS OpsWorks stacks, and they allow us to define different parts of our application with layers. And each one of those layers will have a chef recipe to define the configuration and resources inside of those layers. As a cloud practitioner, you don't need to really understand how Chef or Puppet works. You just need to understand that AWS OpsWorks is a fully managed installation of Chef or Puppet. Here is how OpsWorks for Chef Automate or Puppet Enterprise works. The AWS OpsWorks service will deploy compute resources that will be running Chef Automate or Puppet Enterprise. And that instance will deploy and manage the configuration of instances that are running our applications. And here we can see AWS OpsWorks stacks and how it works. So here we can have an OpsWorks stack, and that will define 3 layers there. We have a presentation layer, an application layer, and our data layer. And they will be defined using a chef recipe. And those chef recipes and the OpsWorks stack will then manage the configuration of each one of those layers. Now, not all of the AWS resources can be deployed directly by OpsWorks. For example, here we've got an Amazon RDS instance, and you can deploy that yourself and then refer to that in your chef recipe if you need to. There are many deployment options available on AWS. You can use those individually, or you can manage them and automate them across the entire lifecycle. On the left there, we can manage our code with code commit, which is a repository for our code that runs Git. And so it's very similar to GitHub if you've used that before. And once we've defined that code and we're managing that code in code commit, that can allow any changes that are made in our code in that code commit repository to trigger a code build job, which can build our code for us. And not only build it, we can implement testing to make sure that not only our code actually compiles, but it also works exactly how we expect it to. And once we have our production ready code, we can pass that on either manually or again automatically to codedeploy, and codedeploy will get that ready for deployment. And you can then pass it on to CloudFormation that will provision those compute resources for you. And then once all of those compute resources are up and running, and they're running our code that originally came out of our code commit repository, we can then implement CloudWatch to continually monitor those deployed resources. We could also have AWS manage that deploy, provision, and monitor part for us using OpsWorks or Elastic Beanstalk. And then we could actually just have the production ready code simply passed on to Elastic Beanstalk or OpsWorks, and that will look after everything for us. And if we wanted to take that one step further and we wanted to manage the entire process from code through to final monitoring, we could use Code Pipeline to manage that entire process and automate that entire process for us. Another term that you will hear a lot is CI/CD. Continuous integration. You may have many developers working on the same code, and this will allow those developers to merge their code changes and commit those code changes back to a shared branch. And when those code changes occur, that can trigger the building and automated testing of code for errors. And so there we could use code commit, and all of our developers will be working off a code commit repository. And then they will check those, or they will commit those changes that they make, and those changes will trigger a code build job that will build and then test that new code for them. Continuous delivery is when the code is delivered automatically for approval. And that approval process could be automatic, although most people do like to have a human going over that before we have approval of production ready code. And then when we have our production ready code, that is automatically deployed to our AWS resources. And then the performance of that deployment will be monitored from there on as well. So our continuous delivery will be occurring at the start of the code deploy, OpsWorks or Elastic Beanstalk process there. And then once that code is deemed to be production ready, it can be deployed, provisioned, and monitored by one or many of those services. And of course, we're going to be continually monitoring the performance and rolling back if there are any issues that are identified. Elastic Container Service, or ECS for short, is a fully managed container orchestration service for Docker containers. Now, you don't need to know much about Docker at all as a cloud practitioner, but you do need to know that the ECS service is for orchestrating those Docker containers. And it does that by first provisioning our EC2 resources for running those containers. And it also configures those compute resources. For example, we may want to run a bash script or something like that when those resources are deployed or when those resources are created. And then we can deploy our containerized applications in those Docker containers to our EC2 resources. And of course, we could always implement auto scaling of those EC2 resources, and we could also monitor those resources using CloudWatch. The Elastic Container Registry, or ECR for short, is a repository for our Docker containers. And it allows our applications that are on those Docker containers to be stored in ECR and shared and also deployed directly from ECR as well. Our applications can also be deployed to a serverless environment instead of having to use EC2 instances, and we do that using the AWS Fargate service. So here we have on the left-hand side the ECR that contains all of our Docker images, and the Amazon Elastic Container Service can fetch those Docker images when required. So we can define our application, which will define what images, what container images are we going to be using, and also what resources we are going to be deploying those containerized applications to. And there we can see we've got Fargate for serverless environments. We can deploy to different regions, local zones, AWS Wavelength, the mobile environment. We can also run that on premises using AWS Outposts, or we can also use ECS Anywhere, which is another feature of ECS that enables us to easily manage and run our containers on our own customer managed infrastructure. And when our containerized applications have been deployed, the ECS service will automatically scale and manage that for us for availability, and it will also monitor the performance of our infrastructure that is running on as well. Elastic Kubernetes Service is a fully managed container service to run Kubernetes applications. Kubernetes is an open source platform for orchestrating containers. It automates the deployment, scaling, and management of containerized applications, such as those built using Docker. And it does that as a cluster of resources. So EKS, it's very similar to ECS, but it's using the open source Kubernetes application. So you may want to use Kubernetes instead of ECS because you've used it in the past on your on-premises applications, or you've used it in the past with Google Cloud because it was actually developed by Google, or you've used it with Azure or something like that, and you're comfortable using Kubernetes, then EKS is great for you. Or you can also use ECS. They both will do a very similar job. The EKS clusters are built using the EKS distro, open source Kubernetes distribution. So the process starts by you defining and creating your EKS cluster using Amazon EKS, which again is powered by the EKS distro, open source distribution of Kubernetes. And then once you've done that, you can deploy that to AWS Fargate if you want a serverless environment. Or you can deploy that to Amazon EC2, and that will create a number of worker nodes for that EKS cluster. And once you have that deployed, you can run your Kubernetes apps on that infrastructure. And then, of course, you can view the performance of your apps in the EKS console. There are a number of different strategies that we can employ when we're doing our deployments. All at once deployments are very easy to understand. All we're basically doing is getting all of our instances and updating them all at once. As you can see here, while that's going on, the Elastic Load Balancer is going to have nowhere to send traffic to. So you're going to have downtime while that's going on. So you would need to manage extra resources while that is going on if you wanted to maintain availability. So the points to take away here is that all the instances will be updated at the same time, and there will be no availability during that deployment process if no new resources are created. So to make sure that you have availability while this is going on, you need to make sure that the resources are doubled with disposable resources. So in this situation, you could just increase your group size there of EC2 instances from 4 to 8, and you would still maintain availability. And when those new instances are up and running, you could terminate the old instances. Another way that you could do it is that you could also have a replication of that entire infrastructure there. So have another elastic load balancer with another 4 instances there. And you could use something like Route 53 to simply switch the traffic over from one elastic load balancer to the other. And that would do the same thing as well. But an all-at-once deployment does everything all at once. In place deployments allow us to simply update each instance one by one. So as we can see here on the diagram, the one on the left there has been updated, and then we're moving on to the next one and we're updating that. And then we'll go through until all of those instances are updated. As we can also see here, the elastic load balancer will not be able to send traffic to any instances that are being updated. So there our capacity goes down from 4 to 3. So we need to manage that. So the points to take away here are that each instance is stopped and updated individually. No new resources are created, and because of that, the availability can be affected during the deployment. Rolling deployments are similar to in-place deployments, except that we add an additional instance to cover that instance that is being updated. So here we can see here we've got a new instance that has been deployed, and that will have the new code on it. And so once that has been deployed and it is up and running, that one on the left there, then we can go through and update each one of the old instances individually. And so there we can see that we at all times will have traffic served by those 4 instances, because we, at the start of the process, we deployed that extra instance. The points to take away: an extra instance is created during that deployment, and then one by one, each instance will be updated, and the last instance to be updated will actually be terminated. And that is because we added that extra instance at the start. So here we can see we've got 5 instances, but we only need 4. So when we get to the last one to be updated, we can simply delete that one, and we will have the required capacity of 4 instances. The advantage here is that availability will not be affected during that deployment. With blue-green deployments, we will have 2 identical architectures. The blue architecture will be our live architecture, and that will be receiving live requests from our domain. We will also have an identical green architecture there we can see on the right. And that is used by our developers to build and test our code and get it ready for production. And so when our code is production ready and we've tested it on our green environment, then we can simply use Amazon Route 53 and change our DNS records that are pointing to our blue environment to point to our green environment. And so then all of that traffic is now directed to our green environment. And if we identify any problems, we can always go back to Route 53 and change that DNS record again to point back to our blue environment. When we're satisfied that our green environment is now our production code and we're going to continue with that green environment, that green environment will then become our blue environment. It will be our live environment, and then our old blue environment will become our green environment. The points to take away here is that blue-green deployments have minimal, if any, downtime. The other advantage is that if we identify any problems, we can quite simply roll back to our old blue environment by simply changing those Route 53 DNS records again. The downside is that we're always going to have double the resources that we require to run our production environment. A canary deployment is a two-stage blue-green deployment. And where it differs is that instead of directing 100% of our traffic over to the new environment, what we can do is that we can get Route 53 to direct half of the traffic to the old environment and half of it to the new environment. And then when we're satisfied that everything is okay, then we can simply direct all of the traffic to our new green environment. So the points is that it is a two-stage blue-green deployment. We do 50-50 at the first stage, and then we do 0 and 100% to the new environment. It provides reduced risk, but the extra stage does increase that deployment time. Linear deployments are incremental blue-green deployments. And what we can do is, instead of just going 50-50 like we do with a canary deployment, what we can do is that we can start off by sending 90% of the traffic to the blue environment and 10% of the traffic to the green environment. And then at the next stage, we can do 80% to the blue environment and then 20% to the green environment, and keep working our way down until we get all of that traffic from the blue environment transferred over to the green environment. And again, if we identify any issues along the way, we can always go back and change our DNS records to point back to the blue environment. So the takeaways here are that linear deployments are incremental blue-green deployments. We change the traffic from the blue environment to the green environment in staged increments. It has reduced risk, but these increments will increase the deployment time. So that brings us to the end of our discussion on deployment on AWS. I hope you got a lot out of it, and I look forward to seeing you in the next one. Welcome back to Backspace Academy. Before we start the lab, make sure that you've got a copy of the blue-green deployments on Elastic Beanstalk lab notes. Okay, so starting off, we go to the Elastic Beanstalk Management Console. So we'll just search for that, and there it is. And the first thing we're going to do is to create an environment, and that will be our blue environment. And it will be a web server environment. We'll give it a name. And we'll call our application blue-green because we're going to be using this application for both our blue and our green environments. But our environment name is going to be called our blue environment. And we're going to select a managed platform, which would be Node.js. And we're just going to launch the sample application. So what we're going to do now is that we're going to create an application called blue-green, and we're going to deploy that application to an environment called blue environment or blue-env. And the application code is going to be Node.js, the sample application supplied by AWS. So let's create that environment now. So that's going to take quite a while to get up and running. It's going to launch that EC2 instance and launch that application as well. So I'll just go away, have a cup of coffee, and come back and it should be done. Okay, so our blue environment has been created. What I'm going to do now is just click on the environment URL here and just see what it looks like. And there we can see is our sample Node.js application created by AWS. So we're going to make some changes to this, and then we're going to launch that or relaunch that as our green environment. So what we'll do is we'll create our green environment now. And the quickest and easiest way to do that is just to go to Actions and clone this environment. So I'll do that. Okay, so the environment name is blue environment that we're cloning off. So we need to change that to green environment. Okay, so that's all we need to do. So it's grabbing that original environment there, making a clone, and naming that clone green environment. So we'll just clone that now. So that's now going to go through and again launch that environment. I'll again go away and come back, and after about 5 or 10 minutes it should be all done. Okay, so our green environment has now been created. I'll just click on the link for that one as well. And there we can see that one's working fine as well. So they've both got the same application code installed of them. What we're going to do now is create some new code. So what we'll do is go into our application versions here for blue-green application. And there we can see it's using the sample application. So what we can do now is that we can get a hold of that source code and we can modify that and then upload it to create a new version. So just click on that now. And we'll scroll down here to sample applications, and there is our Node.js sample application code. So we'll just download that. There it is. Okay, so I've just extracted that file, and there you can see what I'm going to do now is just open up index.html in a code editor or a text editor, whatever you want to use. I'm just going to use Visual Studio Code, but you could use anything. You could use Notepad or something like that. It's completely up to you. So here is that index.html. So what I'm going to do is just modify this. So we go down here to line 38, it looks like. We've got the background color for that text column. And we can see here it's a green color. So what we're going to do is just change that and change it to orange. There we go. And I'll just save that. So what I'm going to do now is just zip that back up again. So select everything and just send that to a zip file. So there we go, that's done. And when you open this up, make sure that when you open up that zip file, it looks like that. Make sure everything here is not hidden inside of a folder or anything like that. Just make sure that it looks like that. That will be fine. So what we can do now is that we can update that as a new application version. So we simply go to upload and we'll leave that version label as it is. We'll give it a description. Orange background, that will be fine. We'll just choose that file and there it is. And we upload. Okay, so that's uploaded now. What we can do now is we can deploy this orange background one to one of those environments. So we'll do actions. Well, first of all, we select that version. We do deploy. And we're going to deploy this to our green environment, because remember, our green environment will be the one that we're developing and we're working on, and then the blue environment will be our production environment. So we'll select our green environment and we'll deploy to that. So let's go to our green environment now. And there we can see that it has successfully deployed that. So let's see if there's any changes. So I'll just click on the URL. And there we can see that our orange background has been achieved and we've made that update. So that's fine. So now our green environment, we can see there, is our development environment. And if we go to our blue environment, and we look at that URL, it will be different. So there we have that original. So our production environment, our blue environment, has the old version still. In a real application, what you would do is that you would do all your testing on this green environment, make sure that it is all working, and then you would do DNS cutover to change your production environment to point to this green environment that you have just developed. And you do that with a DNS swap. So what we'll do is we'll see how that occurs. So let's go back to this blue environment here, and we go to actions, and then swap environment URLs. And what's going to happen is the environment URL, which is blue environment, will end up pointing to the green environment name, or the application that is running on that green environment. And so we're going to swap those two over. And so our green environment, our new environment, will be on our blue, our production environment URL. So let's select that environment name, green environment, and we click swap. Okay, so that's done. So let's have a look and see what happens. So our blue environment here is now using our green environment. So we'll just click on the green environment, and that should go to our old. So it should be that. So there we go. So that's our original, our old our version of our application. And that's right, because our blue application now becomes our green application that we're going to be developing on. So now if we go to our green environment, which is our new environment, our new application that we developed, that is now pointing, or our blue environment URL is now using the green environment application. So we'll click on that now and we'll see what happens. And so there we go. So our blue environment URL is now using our latest code. And so that's the way it all works. A little bit confusing with all the blues and greens. So what you would normally do if you're going to set this up yourself, you would probably give your applications or your environment names, environment 1 and environment 2, and you would have your URLs when you create them, you would have them as blue and green, so you wouldn't get confused. But I've done it this way just so you can see that it has actually changed them over. So you can see here green and blue, so it's very easy to see what's going on. But again, in a real life environment, you would probably call your environment names environment 1 and environment 2, or environment A and an environment B, and you would have your URLs where you would be called green and blue. So that brings us to the end of the lab. What we've got to do now is clean this all up. So we go to actions and we terminate the environment, and we just need to put the name of the environment in there and terminate. And then we go to our blue environment. We need to terminate that as well. And we'll terminate that environment. And those should both be terminating now. So we go to environments and we'll refresh this. And we'll select each one. So we'll just open that one up and this one up. And we can see that one is terminating now. And our green environment is also terminating as well. Okay, so give that a little bit of time and they will both be terminated. I hope you got a lot out of this, and I look forward to seeing you in the next one. Welcome back to Backspace Academy. In this lecture on CloudFormation, I'm just going to give you a brief overview of the CloudFormation service. As a cloud practitioner, you're not going to need to know CloudFormation in any technical detail at all, but you do need to understand what it's all about. So we'll have a look at the template structure of these CloudFormation templates in JSON and YAML. We'll look at the different sections and how they all work. And then finally, we'll have a look at the CloudFormation Designer. CloudFormation, it allows us to implement our infrastructure as code. We define our infrastructure in the format of a text file containing JSON, which is JavaScript Object Notation, or YAML, which stands for YAML Ain't Markup Language. So we just define it in that format as a text file. When we've done that, we can use our existing version control tools, for example, Git, to implement version control on our infrastructure the same way that we do with our code. The CloudFormation template, it will describe all of the AWS resources And when we supply that CloudFormation template to the CloudFormation service, it will take care of provisioning of those resources and also configuring of those deployed resources. All of our related resources that are defined in our CloudFormation template or multiple templates can be managed as a single unit called a stack. And those stacks of resources are managed using the AWS Management Console. After you've deployed a stack and it's up and running, and you need to go back and change something, you can generate a change set. And that allows you to view the changes to your resources on a review screen before you actually implement those changes. CloudFormation templates, as we stated before, are text files in either JSON or YAML format. CloudFormation JSON templates define the sections of the template as JavaScript objects. The configuration of these objects is surrounded by brackets. So there we can see we've got a description, which will be a string. We have resources defined as an object, and inside of those brackets, we will list a set of those resources that we are going to be deploying. Here we have the YAML format, which is exactly the same as the JSON format, except instead of surrounding our objects with brackets, we use indentation to format those objects. So they both achieve the same thing, but YAML is good if you want a very neat and tidy looking CloudFormation template. The downside is that sometimes it can be a little bit more difficult to see where the errors in your template are because the objects aren't surrounded in brackets. The CloudFormation template is made up of a number of different sections. The first section is the format version, and that simply states what version of the CloudFormation template language you're actually using. Next, we have a description, which is simply a description in text of what the template's about. It can be whatever you want. You could also attach metadata, which would be JSON objects in the form of keys and values. If you want to put something specific in that template, you could put that in as metadata. Parameters are very useful if other people are going to be using your CloudFormation template. What you can do is define parameters so that when the CloudFormation template and the stack is being created, before it is created, the CloudFormation service can prompt the person that is deploying that CloudFormation template for parameters. For example, it might be to ask for what type of EC2 instance do you want to launch. You can implement mappings of keys and value pairs, and those can be referred to within your template. You can define transforms that can prepare this CloudFormation template for other services such as the serverless application model. Outputs can be very useful when you want to see what is going on with your CloudFormation template. You can put at different stages outputs that can output a message to the console when something of importance has occurred. The resources section is the most important section because it is required. If you don't have a resources section, then there will be no resources to deploy, and the CloudFormation template actually won't work at all. So that is required, and it simply declares the resources that are going to be deployed. Conditions, they define when a resource can be created or a property can be defined. For example, you may put in a condition that an EC2 resource cannot be deployed until the VPC has been created. Now, as a cloud practitioner, you're not going to need to be a technical expert on CloudFormation templates. So what I've done there is just highlighted in yellow the sections that I think that you probably need to understand for the cloud practitioner exam. CloudFormation Designer is a tool that you will use a lot if you're going to go on and do the associate level course with Backspace Academy. It's a visual tool that provides a drag and drop interface for adding resources to that template. and it automatically will produce a CloudFormation template for you in either JSON or YAML format. There we can see on the left, we've got the resources that we can drag and drop over onto that screen. And on those resources there, you can see that we've got some arrows linking them up. And so that's going to show conditions or any relationships between those different resources. We've also got some colored dots on those resources as well. So clicking on those will allow us to configure those resources as well. And all of those changes that we're doing visually using that console will be automatically updated in that JSON or YAML CloudFormation template. So that brings us to the end of this discussion on CloudFormation. I hope you got a lot out of it, and I look forward to seeing you in the next one. Welcome back to Backspace Academy. In this lab, we're going to be launching the sample AWS LAMP stack, which is a Linux Apache MySQL PHP installation on an EC2 single instance. Now, before we start the lab, make sure that you've got a copy of the Introduction to CloudFormation lab notes. So we start off in the CloudFormation Management Console, and of course we get there by going to or searching for CloudFormation, and there it is. And we go to Stacks on the left here, and we're going to create a stack, and we're going to be using new resources. And we're going to be using the sample template from AWS, and the sample template will be a single simple instance, not a multi-AZ, so it's a simple LAMP stack, and that will create a LAMP stack using a single EC2 instance and a local MySQL database for storage. So it's not going to be launching an RDS database, it's going to have that database on that single EC2 instance. So it's going to save us a little bit of money, so that's what we want, and we'll run that on a T2 micro, so it'll be under the free tier as well. So we'll select that, and we'll click on Next. We'll give the stack a name. And we'll leave that database name as it is, that's fine. We'll just put in a password. I'm just going to put in anything here because I'm not going to be connecting into the database at all. So I'm just going to put anything in there. DB user. Again, I'll just put in anything I want because again, I'm not going to be connecting into the database. We're just going to launch this and then terminate it afterwards. The instance type, we don't want to select a T2 small. We want a T2 micro because that's going to be on the free tier for us. We need to select a key name. You should already have a key pair already for some EC2 instances that you've previously launched. So we can select one of those. If not, then you'll have to create a key pair. And everything else looks fine. And we'll click on Next. And we don't worry about saving that password. So when this fails, what do we want to happen? So if this doesn't work, there's a problem with the template or something like that. We just wanted to roll back all those stack resources, or there is another option where we could preserve those resources that were successful in launching and then manually maybe do the others. I don't like to do that. It's good to have a template that works. So we're going to roll back all stack resources and we'll make sure that we get it right. There's quite a few advanced options which we won't go through. And we'll click on Next. So there we can see there is our template. It's an AWS managed template that we're going to be using. And there's our parameters that we entered. So remember that name parameters because we're going to reference that, or we're going to talk about parameters after we've launched this stack. But you can see here there's parameters that we have entered of DB name, DB password, DB root password, user, instance type, key name, and the SSH location that you're going to be accessing from, and we've just got it from anywhere here. So those are the parameters that we had to input, and everything else is just default. So we'll click on Create Stack. So that's going to take about 5 or 10 minutes or so. So I'm going to go away, have a cup of coffee, I'll come back and it should be done. Okay, so our stack has deployed. If you've been waiting quite a while and you don't see anything, make sure that you click the refresh button here on the right hand side there. What I'll do now is I just want to have a look at the template and show you how a CloudFormation template works. So just click on the template tab here, and we can see here it's simply a whole heap of text in JSON or JavaScript object notation. And there we can see we've got some parameters. Now those parameters are what we entered when we created this CloudFormation stack. So here we can see we were asked to provide an EC2 key pair. We were asked for a DB name, a username, a password, a root password. We were asked to select an instance type. And so all of that stuff is in our parameters section of this template. So if we need to get any information from someone who is launching this template, this is where we put it, at the parameters. We've also got an output section here. So if we click on outputs, and we can see here we've got a website URL is the key for that output. We've got a value there, and we've got a description. So if we go back to our template, and if we scroll right down to the bottom of our template, we'll see that we've got this output section here. And we can see it's called website URL is the key. It has a description, the URL for the newly created LAMP stack, and the value is going to be the public DNS name of that EC2 instance. So if we go back again and look at the outputs, there it is. So our website URL and the value and that description. So if we click on this value and just open up into a new tab, that will take us to our website. And so there we can see it has deployed our LAMP website for us, and that's all working fine. And so one thing that we could do is we could have a look at this if I go back to template, we can also view this in the CloudFormation Designer. So I'll just open that up now. And the CloudFormation Designer allows us to drag and drop on a user interface here and draw our infrastructure on the screen. So if we go to the left-hand side here, we can see the resources that are available. So we could scroll down to say EC2. If we wanted to launch another instance, we could just select the instance and simply drag and drop it on there. And there's our other instance. If we make a mistake, we can just click on undo and get rid of it. And here we can see, so we've got two resources that have been created. We've got the web server and the security group for that web server. And down in the bottom pane here, we've got the template, which is quite a long file here, which has got a whole heap of stuff in there. But if we just wanted to see the parts of the template that were related to the web server, we can just click on the web server, and there we can see it's going to define the region, the instance type, and there we go. So that's just the component of that CloudFormation template that relates to the web server. We could also have a look at the web server security group. So we click on that, and again, components. We can see here it defines that web server security group. So we've got protocol, TCP, port 80 for HTTP access. And we've also got port 22 for SSH access as well. So there's our security group defined. And we create a relationship between our web server instance and the security group by just clicking on one of these tabs here. And here we can see, or one of these dots. And here we can see it will change color. And we could click on that and then drag that over to here. And that's how we create that link between the web server and the security group. And we do that completely visually. We don't have to do anything in code at all. It just creates that all for us. Now, you don't need to know much about CloudFormation Designer. Just know that it's something that you can drag and drop onto a screen and connect things together, and it will automatically produce your CloudFormation template for you. So I'll just close that now. So that brings us to the end of the lab. What we'll do now is clean this all up. And now it's created some resources. It's created an EC2 instance, and it's created a security group. But when you launch something with CloudFormation, you need to make sure that you delete the stack, and the stack will delete all of the resources. Do not go and delete the individual resources, because then when you have to go back to delete the stack deletion process will fail. So we did the way to do it, and to do it cleanly, is you simply go to our stack, our backspace-lab stack here, and we just click on delete and delete stack. It's as simple as that. And we'll just have a look at the events, and then we can see that we have a delete in progress. So it's deleting that web server instance, and that's going to take quite a while. So all we need to do is make sure that we keep clicking on the refresh button. And after about 5 minutes or so, your CloudFormation stack and all of its resources will be cleanly deleted. Okay, so I hope you got a lot out of it, and I look forward to seeing you in the next one.